Okay, in this lecture, we're going to go over how to complete Excel workbook 2-3-2 and just go over how to use that. And very specifically, we are looking at normal probability distributions and how to calculate probabilities associated with normal probability distributions. And so I'm going to go ahead and share my screen. So let's see here, share screen. There we go. Now with normal probability distributions, like I said, there's lots of different things that you can use. You can use the Z table, which I have entire lectures going over how to use the Z table. Right here, you can watch the lecture going over Z tables, and normal probability distributions. And then there's also more information in here, but I'm going to show you very specifically how to do the Excel work and how to do this much quicker with using Excel formulas. So I'm going to go ahead and pull up the Excel document. Let's see here. Excel, Unit 2 Excel, right here. Yours is going to look slightly different. What I did, well, I'll just do this. Um, This is what yours is going to look like. And one thing that you can do is you can increase, you can insert several columns, and put whatever other information you want in there and solve for whatever missing values you have. So right down here, you'll see to find the value that you want. Um, you have to follow this information down here, but we'll get to that in just a minute. So we've got the Z. Let's see here, printable resources. Um, the Z table. There we go. Z table. And there's an entire lecture that shows you how to use the Z table, which the Z table is all well and good, but it's, just outdated and you can use Excel and it's a lot faster and a lot more accurate to use Excel. And so I'm going to show you how to use Excel in this lecture. So say for instance, we have any sort of situation. We've got the Z value, we've got a score, we've got the mean, standard deviation, so on and so forth. So, in this particular situation, you have that has 116 students who took an exam, and you want to know, hey, how did I compare, or how does an individual compare to other individuals with a particular score that they got? And so depending on the information that you have, you can solve for everything else. So we're just going to kind of work through this and solve for it. So with a z-score, right here, you've got this 1.33. Like I said, you can use a z-table, and let's start with negative 1.32. This z-table right here, let's just go ahead and download it so that way it's a lot easier to look at. Um, and we will look at this right here. So we've got the z-score of negative 1.329. So we come down here, negative 1.3. This is negative 1.30, because remember it's right here, negative 1.30, negative 1.31, negative 1.32, and this is really most close to negative 1.33. So negative 1.33, we find that intersection negative 1.33. So it's 0.0918 would be the probability of having a score that's lower. Okay, so that's right here. And then what is X? So in order to solve for X, we just need to rearrange this formula. So we're going to put X all by itself. So multiply both sides by the standard deviation. And then we are going to which gives us this right here. Um, and then if you do just a little bit more, you can, let's copy this. add the mean to both sides, which gives you x equals z multiplied by the standard deviation plus the mean. So we're going to do equals the z-score multiplied by the standard deviation plus the mean, and that will give us the score of 85.01. So now we have x. So just by rearranging this formula a little bit, we can get x. How do we solve for just the mean? Once again, we just have to solve. So we'll just take this exactly how it is. And we can subtract this from both sides. It's just rearranging the formula. So now we can solve for just the mean. So now we have x minus z multiplied by the standard deviation. So this one right here is missing the population mean. So we'll go ahead and solve for that. So we do equals sample mean minus z multiplied by the standard deviation. Whoops. And that gives us a mean of 83. And then coming right down here, we want to solve for the standard deviation. This one's really easy to rearrange. We're just going to multiply both sides by the standard deviation and divide both sides by z. And so now we have standard deviation equals x minus the mean divided by z. And so this one right up here has that missing value. So we'll do equals uh, in parentheses x minus the mean um, divided by the z-score, which gives us the standard deviation. And so now we have the standard deviation of all the various exams. We've got the mean, we've got your individual score. Actually, we don't have it right down here, but you guys can solve for that on your own as well. And then we have the z-scores. The other thing that we have, so right here, you notice that it's missing two of the values. Well, you need at least three values in order to solve for a missing value. But you do have this value right here. What is the probability of randomly getting below whatever score you got on the exam? So there's 116 people who took the exam. The probability of somebody getting a score lower than you is 0.0013 or 0.13%, which unfortunately means that you probably didn't do too well. Um, so we're going to come down here where it says norm.s.inverse, and we're going to use that formula, and it says, okay, use this and put in the probability of below, whatever it is, the probability of you getting below that. So equals norm.s.inverse, and put in the probability, and that gives us a z-score of negative 3.011. And then we can come right here and solve for x. And in order to solve for x, we are going to do z-score multiplied by the standard deviation right down here. Notice the standard deviation. Okay. And then we are going to do plus the mean. And that gives us, well, you scored 71.93 on your exam. And so that's how you use this. And then also if you want to know, hey, what is the probability of somebody getting lower than you? You come over here to this right-hand side, and you look down here, it says norm.s.dist. And norm.s.dist will give you the probability of getting lower than any particular z-score. If you just use norm.dist, it will give you the probability of getting below. You've got to use these three values. Okay, so equals norm.s.dist. Okay, and then we're going to put in the z-score. And you always put in true. Okay, so the probability of getting below this value right here is 90%. That's great. So what's the probability of getting above that score? Probability of getting above that score equals 1 minus, so we're using the complement rule, this value right here. So the probability of getting above is uh about roughly 9.1% or 9.17%. Probability of getting below is 90.8%. But the next question is how many people, if there's 116 people, how many people scored less than you? So all that you've got to do is equals the probability of scoring less than you multiplied by the number of people that took the test. So we know that there's about 105 people who scored less than you when you scored a 96. So the big question that we have is, uh, so what? How does this apply to us? Well, we can apply this to pretty much anything. Say, for instance, you want to put out an advertising campaign on social media. And you're like, okay, well, we want to appeal to this particular audience. And in order to appeal to this particular audience, um, we're going to do X, Y, and Z to modify this ad. So, say for instance, when you put out a social media ad, you normally get in the course of a day 510 clicks. So whoops, sorry, the mean is 510, gosh, 510 clicks with a standard deviation of 30 clicks. So that means on average, you get 510 clicks per day from an ad that you send out with a standard deviation of 30. So you sent out this new ad, and you're like, okay, we've got a total of 534 clicks. 534 clicks on this ad. Well, automatically you look at this and you're like, oh, 534 clicks. Um, that's above 510 clicks. So the ad must have been more effective. We were more effective with whatever it is that we changed. But the truth of the matter is we've got to look a little bit deeper. Okay. And so let's go ahead and calculate the z-score. So in order to calculate the z-score, we're going to do equals uh, x in parentheses, x minus the mean. Okay. And then after x minus the mean, we're going to divide it by the standard deviation. And that gives us a z-score of 0.8. So what is the percent of ads or that would go out that are less than the ad that you just put out? So let's do equals uh and once again you come down here norm.s.dist, you put in the z-score, type in true, um, and uh, randomly, completely randomly, if you were to just look at other days that you run various ads, any kind of ad, the probability of being less than this day is 78.8%. Which we'll get into this a little bit more in Unit 3 and especially in Unit 4. But what this means is really it's not enough to be able to show that the ad that you ran is actually better. Um, and so, say for instance, you ran an ad campaign for 30 days. Of those 30 days, how many of those 30 days would you expect to be less than 534? So you do equals 30 multiplied by 78. Okay, so roughly 23 or 24 days should be less than 534 if there really is no difference. It's like, hey, the ads are the exact same. They really, whatever it is that you changed about it really didn't make much of a difference. And if that's true, roughly 23 days will be less than the this score that you got right here. And you can apply this to pretty much anything. Okay. So say for instance, I've got this Lego set right here. With this Lego set, it is a total of 318 pieces, and it is a $26 Lego set. So if I look at all $25 Lego sets, I can go to, let's see here. Let's go to lego.com. Okay. And then let's go shop, price ranges under $25. Let's do sort by high to low. Okay, so we've got some Lego sets. And it just happens to be that, let's see here, open a new tab. Oh, yeah, it has it right here. 319. Uh, this is great. Okay, so, whoops. We want to know, are we pricing Lego sets, uh, according to the number of pieces that they have, are we pricing them at the right amount? Okay, so we've got one that's got 319. We've got another one that's got 246, 261, 280, 325, 136. Let's see here. 358, 252, and these are all the exact same. Let's see, 336. These are all the exact same price. And keep going down. A lot of things that are 24.99, 258, 254, 220. Let's see here, 272, and we'll stop right there. So we want to know, what is the average number of pieces in a Lego set that costs 24.99? So equals average 270.53 pieces. So we're going to go ahead and put that right here. Paste the values. Um, and then we have a standard deviation. So let's check the standard deviation of the sample. So equals standard deviation of a sample. And I just took the first how many ever that showed up. So it's 57.34. Paste values. And so we have this Porsche set right here. Or sorry, not Porsche, it's a Ferrari set. And there are 318 pieces. So I want to know, uh, is this set overpriced? Is it underpriced? Is it right on the right price point? Where is it in relation to other sets that are 24.99? So let's calculate the z-score. Equals. Uh, we've got x minus the mean, um, divided by the standard deviation. So we've got a z-score of 0.8276. So what this means, let's come over here and say, okay, what's the probability of other sets that are 24.99 being or having less pieces than this Ferrari set? So we're going to do equals, um, we're going to come right down here, norm.s.dist, norm.s.dist, and we're going to put in the z-score. We're going to type in true. And there's a 79% chance that if you have another set that's 24.99, that it's going to have less pieces than this set. So say for instance there's 40 sets that are 24.99. How many of those 40 sets should be less than should have less pieces than this Ferrari? So equals this multiplied by 40. So roughly 32 sets will have less pieces. What's the probability of a set having more than 318 pieces? And it's going to be equals 1 minus this, and it's going to be roughly 20%. So we'll get into this, like I said, in Unit 4, but that means that this is probably, the right price in comparison to the other sets that are 24.99. And it's got the right number of pieces, and you can sell it for that amount, for Lego. And so you can put any example in here that you want the big thing is you put in all the information that you have, and then you can solve for the missing pieces. What I would suggest on your formula sheet or whatever it is that you have, you can, put this table, put something on there, and then put those Excel formulas in there. However, it's going to help you to be able to solve for whatever's missing, so that way you're not a deer in the headlights and being like, oh my goodness, I don't know what to do. So yeah, but that's how you use this, and it's a really good tool. But yeah, you're putting it on your formula sheet in a way that you can replicate it in Excel is something that'll be really beneficial to you.